Hello everyone and welcome to this introduction to machine learning tutorial. In this video we go through a multiple linear regression example for beginners. Now please note that this video is actually video part 2, and if you haven't watched part 1 already, I'm going to have a link in the description. I highly recommend you do that first because I explain what is machine learning, and then I also explain all the steps in the machine learning process and the tasks involved in each step. Additionally, I also explain the problem we are trying to solve in this tutorial, and I also explain what packages or libraries we are using for this tutorial and how to download them and install them. Last thing I explained in video 1 is from where to download the raw data for this tutorial and the code, the whole notebook I'm using for this tutorial. Right. Starting from step 4 now, which is loading the raw data. As soon as you download the raw data from the link in the video description, you save it in a folder in your PC, and then to load it into Python, you have to say, actually we have to run first our libraries because I want to run them. So we click Control and Enter to run the libraries, and then we can say raw data equals pd.read_csv open brackets. So here now we need to paste the location that we saved our raw data. So I saved my raw data into this location. So all you have to do is click on the path, copy the path, then go back into Python, paste the path into quotes, and then in the brackets. Also use a forward backslash always, because now we only have 1. So I'm just going to use 2, and then 2 at the end. And here at the end, I need to put the name of our file. So I go back into the folder, I double click here, I copy the name, I go back into Python, I paste the name, and at the end I say .csv because this is a pd.read_csv. Now if I run this, I get no error because it worked. I want to print the shape, so I can copy this, paste it down here, and then say print.shape. Shape, and then close brackets. We can see we have a total of 185 rows, so observations, and 11 columns. And then if I want to run the first 5 rows of the data frame, just to visualize the data that we have, I can copy this, paste it down here, and say .head. And then in the brackets, I can either put 5, or if you don't put 5, the default head or bracket is 5. So if I say 3, we can see the first 3, and then if I leave it empty, it's going to be the first 5. Now, please note that in a real life scenario, you're going to have more than one file in this phase, which is phase number 2, gather the raw data. But just because we want to keep this tutorial simple, I've put all the raw data in one file, so we can work only with one file. Right. So the next thing we want to do is to investigate our data set or data frame, which is the data pre-processing phase. So here we want to investigate all the columns and the rows, so number of observations, number of features, if they have null values, their distribution, duplicates, if there are relationships, etc., etc. So it's everything we've discussed in part 1 video in the data pre-processing phase. Right, the first thing we're going to do is to investigate if our raw data has any null values. And null values mean empty data or empty rows, empty observations, data that is null, it doesn't exist. To do this, we can just copy and paste our data frame, and then say .isNull, and then open and close brackets and run this. So this is going to return by observation and then by column if we have any null values, true or false. So as you can see, majority is false, but here down at the end we have true values. However, because we have big data sets and we cannot investigate everything by row, additionally we don't even see the whole data set, we want to somehow summarize everything by column. So how many null values or missing data we have by column. To do this, I can just say at the end here .sum, and then open brackets and close brackets, and run this. So now what we have is our columns. So all these 11 columns, and then next to each column we have the number of missing values. So this is the isNull here. So we can see we have about 3 missing values for all these columns apart from date. So the next thing we want to do, the next thing I always do, is to visualize those missing values, or the null values, to see if there is a way to deal with them. And I'm going to explain what do I mean later on. So to visualize the null values now, all I can do is just call them by saying row data, open brackets, row data again. I can choose any column that has null values. I'm going to go with week, but any column is going to work. Without the space, and then just say equals, or just say dot is null, no, equals, and then run this, and then my error is null takes one position. Oh, I need to open and close brackets, sorry. There we go. So this is the three. We said we have three observations that have null values, so 1, 2, 3. And as you can see, because we have null values across all the columns, it's not like we are missing just the year or just the number of visitors or one variable within the whole observation. We are missing all of them. So in our situation, what we have to do is to delete the whole observation because we cannot fix it. However, a lot of the times in machine learning projects, you're gonna be missing only one value. So let's say you are missing revenue or you are missing promo. So in this case, you can then decide if you want to use the most common value or the average value to replace your null values, so you don't miss any observations. So you keep your observations high up, and then you fit them into your training model. However, in our case, because we are missing the whole of the observations, the whole of the row, we're just going to delete them. To delete them now, all you have to do is copy and paste the name of our data frame, and at the end say dot drop NA and open and close brackets. And let me just run this so we see what it does. So what this does is that it drops any observation that has NA values from all the variables, all the features. However, in our case, it works because we don't want to keep them. But if you want to drop the NA values from a specific column alone and not from the whole data set, you can just say subset in the brackets and then say equals, and then into square brackets and quotes, just put the name of the column, and in our case we choose week, and then paste it in. If I run this, it's going to return the same thing. Remember, this did not update my current data frame. What I have to do now is to copy the name of the data frame at the beginning and say equals, or I can do comma in place equals true. I'm not entirely sure if that's going to work in drop NA, but this is going to work. So if I print the shape now, so I'm just going to copy quickly and print the shape so we see what this is going to do. So what this did now is that it deleted those three observations. And if I scroll at the top, you remember how we had 185 observations. And now because we've deleted three observations, these three observations that had null values, we have a total of 182 now observations, so number of rows. And additionally, if I want to rerun the test now to see if I have any other null values, because remember, it might have been 3 in week, but these 3 on a different observation. However, because we've seen everything is together now, we know that is all in the same observation. But if we didn't, then we need to rerun our check just to check if we have any more. So what we see here is that we don't have any other missing values. So we've dealt with our missing values. Right. The next thing we want to do is to investigate all the elements within each feature. And what do I mean by that? So if I want to really understand my data frame, I want to write some code that goes through every single column or feature or variable, which is the same thing, and investigate the number of distinct elements and also who are those elements. So what do I mean by that? From the first 5 rows, I can visualize that I have no promo, promotion red, and promotion blue, distinct promotions. However, I might have more and I don't know it. So I want to be able to visualize how many distinct elements I have per feature and which are those distinct elements. To do this, I'm going to come down here and write a for loop. So I'm going to say for column in, and then here I'm going to put my raw data, so my data frame. And then the first thing I want to do is to save the unique values per feature. So I'm going to say unique unique underscore vals equals, and then I need to say mp.unique, then open brackets, I need the unique values for each column. So what this is going to do is going to select the first column, and it's going to save with this query here. It's going to save the unique values of the first column into unique values. The next thing I want to do is to count. So how many unique values do I have? Because here I'm just saving the unique values. So here it's going to be a string which is going to say no promo, promotion red, and promotion blue, for example, for promo. But now I want to count them. So to do this, I can say I need the number of values. So I can say I need the length. So this is going to count the length of the unique values. And next, I want to print. So I need something to say if the number of values is more than, and I'm just going to say 10 now, because for date, for example, we have so many different distinct dates, and I don't really want to print all 180 days. So I'm going to add a rule now, which is going to say if the number of values is less than 10. So here is where I want to actually print those values just to be able to visualize them. So I can say print the number of values for feature, and then here I need my first feature, and then I'm going to put space, and then I'm going to put this. So I'm going to say dot format. I'm going to explain you what I do in a second. So in the format, I need the feature. So I'm going to put column. So the number of values for feature, and then the column is going to come in, and then I need the number of values, which is going to be this one, number of values. And I also want to leave some space, let's say. So let me see, this is the second. And I also want to leave some space and print the third thing, which is actually going to be those unique values. So copy this, paste it here. So each time I use these brackets, it's not square brackets, these correspond to column, the second one corresponds to the number of values, and the third one corresponds to the unique values. Additionally, I want to add an else statement here, and I'm going to say if the number of values is more than 10, then I don't really want to print the unique values, but I still want to print everything else. So I can just copy this, paste it here, and I'm going to say the number of values for feature column, correct, and then the number of values, and then I don't need the third thing because I don't really want to print anything that has more than 10 values. It's too much. And if I run this now, you're going to understand what I was doing all this time. So what this does is it says the number of features is actually then distinct, the distinct number of values for feature date. So it started with the first column we have, which is date, is 182. And this 182 is actually the same with our shape, which we've printed here at the beginning. So remember, we've removed 3 columns, so 3 rows, observations. So now we have 182 distinct days. Moving on, we have 28 distinct weeks. So we know that the whole year has 53 weeks. So this means that we don't have a whole year's worth of data. We have 28 distinct week IDs. So that's fine because they correspond to the week. We have 7 months worth of data, and we can actually see those 7 months because this 7 is less than the 10. It printed the values. So this is the unique values. Moving on, we have 7 week IDs, which is fine. We have 2 years worth of data. However, because the months are not complete, we know that the 2 years are not complete either. So we have 2020 and 2021. And because this 2 is less than 10, it actually printed the 2020 and 2021. We have 7 values for the feature day name, which is actually the whole week. So now we know that we have complete weeks. And then the visitors and the revenue, we can see is less than 182 because we probably have days that they have exactly the same visitors, and because this 175 is actually the unique value, is not all the value. And then for marketing spend, the same story. For promotion now, so for promo, we have 3 promotions, and we can see the number of promotions. So this query is very important and very useful. You should actually learn it and copy and paste it in all your analysis. It quickly goes through all your features in your whole data frame, and it flashes out details about those features, very important details where you can understand. They're going to help you understand your data set better. By the way, if you feel that you're getting enough value out of this video, I would really appreciate it if you click that like button and subscribe to my channel. Right, moving on to the next thing we're going to do is that we will visualize our data using SNS pair plots. So Seaborn. If you don't know how to use Seaborn, my previous tutorial was on Seaborn, where I've explained all the major and the most important plots you should know when it comes to data analytics and data science. I highly suggest you watch that tutorial too, so you know how to use SNS and pair plots and all the plots. Right, so the first thing we're going to do is to create a pair plot, which is going to be comparing all the numeric features with all the numeric features. To do this, we can say G equals, G doesn't stand for anything, you can put anything there, SNS.pair plot, open bracket, and into brackets, we want to put our whole data frame. I also have a note here, it says, do not run this one on a bigger data set, just because I'm comparing all numeric columns with all numeric columns now, which I don't really need to do that. It takes a lot of time. You can see it's still running. So do not run it on a big data set. First filter it out, which I'm going to show you how to do later on. Right, so let's investigate what are all these plots. First of all, we have all of our numeric columns on the x-axis and the same columns on the y-axis. In the middle, as you can see, we see the distribution of our data. I'm going to start by saying at the first 5 columns we have, so week ID, month ID, and year, is not something we really want to investigate because they are just daytime columns. Quick facts that we can get is that, let's say the month ID has about 1, 2, 3, 4 or 5 weeks in it, so it's things we already know. Additionally, we can see how many data points. This is the year we have per year, so we have about, I don't know, 10 weeks in year FY20, and the rest, most of our data is in year 2021. And then the distribution of our date columns, again, it doesn't really matter. I would focus more on our numeric columns down here, which is the visitors, the revenue, and the marketing spend. So what this is telling us is that all of them have a slightly right skew distribution. It's actually on the left, but because the mean is going to be on the right, we call them right skew distributions. And additionally, we can also see that revenue versus visitors, we can see a relationship. Marketing spend versus visitors, we can see a relationship. And then visitors versus revenue, as we said that, what was it? Revenue, where is it? Revenue and marketing spend, that's the one I was looking. Again, there is relationships. So the next thing I'm going to do, which is down here, is that I want to slice my pair plot to only select this bit here, which is the one I'm mostly interested, and then investigate this. So to do this, I can say I'm going to copy and paste exactly the same query as above. However, into brackets now, double square brackets, I'm going to put the revenue. So let me just print the columns quickly because I'm a bit lazy to type them in. So I'm going to say columns, run it. So I'm going to put visitors, revenue, and marketing spend, which is my main 3 numeric columns. And then put them in here. And then if I run this now, you can see that I got a subset, which is this subset down here. Additionally, I want to add the category or the hue, which is going to be my marketing spend, my promotion, which is the one I'm mostly interested. So again, if you don't know how SNS Seaborn plots work, watch my previous tutorial. So if I run this now, I get an error because what's the error? Promo. So the error is that I don't have promo in my subset here when I selected from my data frame. So because what this does, it looks for promo in this subset and it cannot find it. So it throws me an error saying there is no promo. So what I have to do is to quickly add promo in my subset. So I'm just going to copy this, paste it here, and then this is going to work. Right, there we go. So I also want to increase the size just to make it a bit bigger, but they've recently changed the size to be height. So if I put height equals 5, There we go, much bigger now, easier to see. Right, so what this did again is slice the subset. It took the subset from our pair plot, and it also separated the data points by promo. So promo, no promo is the blue, promotion red is the orange, and promotion blue is the green. I'm not going to spend time changing the colors now. I'm just going to focus on the results. And the most important thing that we see here is that there are relationships, and also we can separate the promotions. So different promotions perform differently. And if we look specifically on revenue and marketing spend, which is this graph here, we can see that the more marketing spend money we spend, the more money we generate. So in terms of revenue, but for promotion blue, so promotion blue, which is the green, it generates more money. So if you put more money in, you get more money out. So in about marketing spend 3,000, let's say, which is this line here, we expect to generate about 10,000 with no promo. For promotion red, we expect to get back about 15,000. However, with promotion blue, we expect to generate on average, I'm not just saying, all these data points are around 20K to 25K. So straight away from our problem formulation phase, that we said that we want to go back to the business and make suggestions about how to generate more revenue, straight away we have suggestions just by visualizing the data. So this is how strong visualizations can be. We can go back to the business and say, stop running no promo and promo red, run only the green one, which is promo blue, because it generates more money on average based on the marketing spend you put in. Right, the next thing I want to investigate is that I want to copy and paste exactly the same code now and check if there are relationships for day name. So I copy everything, paste it below, and then I change promo with day name. I'm just going to copy day name, paste it in my subset, and paste it in my heap. And then if I run this, I should get exactly the same subset as up here, but this time it's going to be broken down by day name. However, it's very difficult to understand. I have way too many categories here. So what I want to do is to create subplots. So I only want to have one plot per day, and I only want to compare revenue with marketing spend, because this is what I'm mostly interested by day. To do this, I'm going to use LM plots. So I'm just going to say G equals LM dot, SNS dot LM plot or LM plot. I need my x-axis equals, and then I also need my y equals, then I also need my data equals, and then my x is going to be marketing spend, because we want to investigate the relationship of marketing spend. My y is going to be revenue. Copy, paste it here. My data is going to come from raw data. Copy, paste it. And I also, because I also want to see this into, so if I run this, it's only going to return one plot. However, I want to see this plot, exactly this plot with the regression line per day. To do this, I can say comma here, call equals, and then this is going to break it down into columns, well, into plots, but it's called call because of columns, day name. So if I copy day name and paste it in here, it should get 7. There we go. So again, it's not very easy to see. In order to clearly visualize this, I need to say call underscore wrap equals. So what this is going to do is that every 3 plots, depending on the number I'm going to put here, 1, 2, 3, is going to plot the next plot below them. So in a new line, so it's going to be a break. It's like a break every 3 plots. Additionally, I want to increase the size, so it was renamed to height, and I can also change the color of the dots if I want. So I can just say scatter underscore KWS equals, and then these brackets I need to say color colon and then green. And then if we run this, there we go. It's so much clearer now. I can clearly see the days: Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, and Sunday. I can clearly see that there are relationships. So the more, marketing spend, so the more the more marketing we put, the more money we generate. Additionally, I can also remove the confidence interval. So I can say CI equals false or nothing, both work. And I can also change the color of the line, but this is aesthetics now. I'm not going to go into it. You can watch the Seaborn tutorial for this. What this is telling me is that every single day there is strong relationships. It's not like we have a day that is not performing. So what this is telling me is that I should keep day into my data. So I should convert it into a numeric representation, zeros and ones, and keep it in because it does have an impact on revenue. Right, the next thing we're going to do now is to investigate the distribution of our revenue by categorical values. And more specifically, we have day name and promo, which are our two main categorical values that we want to investigate the distribution of the data right now. So to do this, I'm going to use a box plot, but I'm just going to quickly copy my LM plot here, just because I'm lazy to type everything from the beginning. Change my LM plot to a box plot, change my X variable to be the day name, and change the promo, change the hue. So this is going to be hue to be promo. Correct. And then remove everything else I don't need. So I have hue, I have my Y, I have my data come from here. Let's just run this quickly. There we go. So we get a box plot now that is by day. So you can see Monday all the way to Sunday. And it has the 3 different distributions per promotion. The way to interpret it now, the box plot, is that the line in the middle signifies the median. The beginning of the box signifies the beginning of the 25% quartile. The end of the box plot signifies the ending of the 75% quartile. So where does your data sit? The range of the whiskers is the range of your whole data. And then the dots so these dots up here that you see are the outliers based on the box plot calculation. If you want to understand more about how to interpret box plot, you can go back to my SNS tutorial. I'm going to have the link in the description where I explain how box plots and the calculation works. Right, one thing I'm going to do before I start getting insights out of my box plot, I'm just going to change the colors quickly by saying palette equals pal, and I'm going to define pal here with 3 colors. I'm going to say green, comma, let's say red, and let's say blue. I really don't like the default colors. There we go. Right, so how I'm going to use this box plot now is that I'm going to use it to remove the extremes, which is the outliers. So based on what I see here, my majority of my data is between, I'd say, not 0. So these 2 outliers, I'm going to say between 2,000 all the way to maybe just 27,000. So anything after 27,000, so 1, 2, 3 dots, I want to remove them. And just to understand how these dots, what are these dots, if I check Monday up here on my plot, I can see that Monday, this dot here, the one that stands alone, is actually my outlier, which I want to remove. Additionally, if I check these other 2 that I want to remove, which is from Saturday, if I check Saturday, is these 2 points here. Now, I don't really, if it was a real life scenario now, I was not really going to remove them because they seem quite normal to me. It's just extremes, but in some cases, extremes work is what we need to be more realistic and not to overfit our model and to have a more generalized, to increase the generalization. However, because I want to show you how to delete outliers, I'm just going to remove these 3 data points. And to do this, I'm going to come down to cleaning. I'm going to actually select them first. So they come from raw data, open brackets, and then I want to pick revenue. And I'm going to say it's more than 27,000. And I also want to select it. There we go. So if I run this, we can see is those 3 data points, and we can see the data of those data points. They all have revenue more than 27,000. So from here and above, And to delete them, I'm just going to say raw data equals, there's multiple ways of deleting them, but usually I don't do any drop, delete or drop functions. All I do is I'm going to reverse it into less. So it's basically going to select the rest of the data set, and I'm going to pass it back into my raw data. So if I run this now, and then if I run the shape, so if I say raw data.shape, I should have 3 less observations. There we go. So remember, we had 182 the last time we removed the 3 null missing values. Now -3, we have 179 observations. Right. Having done now the exploratory data analysis, the next thing I want to do is to filter my raw data to only include columns I want to use. So you remember all the date columns that we found up here, the week ID, and month columns we are not going to use. I just want to remove them from my raw data that I'm going to use for my regression model. So to do this, I'm just going to select the columns I need. But first, I'm going to print the columns because I'm lazy to type them in. And then to select them, I'm just going to say raw data. I'm going to select them first to visualize them and then pass them back into my raw data. And that's going to be, I want to use the day name we said, the visitors, the revenue, the marketing spend, and the promo. We don't want any date, week ID, month ID, or year. So I copy them, I paste them into my raw data, and then I run it just to visualize them. There we go. This is how my new raw data set is going to look. And I'm going to pass them back into my raw data. I can pass it back into a new data frame now, but I'm going to use the same. And to visualize it, I'm going to say raw data.head. So there we go. We have the first 5 observations from our new data frame. The next thing we're going to do now is to turn our categorical variables into numeric representation. So what this means is that I want to take day name and promo and turn it into numeric representation, just because the algorithm cannot calculate strings. So we have Monday, Tuesday, Wednesday, Thursday here. There is no calculation against that, the same way with promo. So to turn them into numeric representation, we have to create new columns that have zeros and ones. So for promo, we're going to have no promo, promotion red, and promotion blue, and it's going to have 0 and 1 depending which promo they've used. With this way, the algorithm can actually use the categorical column to do the calculations, to do the regression calculations. To do this, I'm going to use a pandas function called getDummies. So I'm going to say pd.get dummies, open brackets. I want to put my raw data, or maybe there is an underscore here, I don't remember. And then I need to say column equals, and then in 2 columns I'm going to start with promo just to show you how it works. And if I run this, yeah, it's called, I think there is an underscore here. And if I run it, there we go, it worked. So see how promo column now is gone, is not here, and it was broken down into promo plus no promo, which is my first, zeros or ones, promo plus promo red, which is zeros or ones, and then promo plus promo blue, which is this one, and zeros and ones again. So the first data point that we can see is Monday with visitors, number of visitors 707, the revenue, the marketing spend, and because it was no promo, it has 1 on no promo and 0 on the other 2. So this is how we can turn our categorical values into numeric, so we can actually use them into calculations and into our algorithms. Additionally, I also want to change day name too. So if I copy day name and add a comma here and run this, there we go, day name is now gone too, and we have the day name into, remember the first one was Monday, so if I search through Monday, there we go, day name Monday, it has 1 on Monday and zeros everywhere else. Now I need to pass this back into my raw data, so I'm going to say raw data equals, actually I'm going to pass it into a new raw data, so I'm going to say new raw data equals, and I also want to visualize it, so I can say new raw data dot shape, shape, what am I doing, shape, and then if I run this, oh, dot head, not shape, sorry, there we go. So now we've turned our categorical data into numeric. There is another way of doing it here in my notes. We can do this with label encoding and then one hot encoder from the pre-processing library, but I generally find this way of doing this, of turning categorical values into numeric, much easier. Right, moving on to the next thing now is the feature selection. Feature selection is the process where we select a subset of our features or variables or columns, all the same thing, to fit in our algorithm. The reason we do that is because in some cases, you're going to have thousands and thousands of features, and it's going to take too much computational time for your machine learning algorithm to work. So the idea is that you have to come up with a way to select only the most important features. And two ways of doing this is the correlation and the feature importance from any tree-based estimators. Now, to run a correlation, we have to select the features we want to run the correlation on, and this is going to be only the continuous features we have. The zeros and ones are not going to work. So that's going to be visitors, revenue, and marketing spend. So let me copy marketing spend. Then if I run this quickly, this is the data set that we're going to feed into the correlation. And at the end, I have to say .core and then open and close brackets. So this gives me the correlation values between all of my numeric continuous features. So just quick notes here. .core is used to find the pairwise correlation of all columns in the data frame. So I said all here, but it's actually only the numeric continuous columns. The closer to, so correlation takes values from -1 all the way to +1. The closer to -1 or 1, the better it is. So the higher the correlation is. As one variable increases, the other variable tends to increase or decrease. That's depending on the correlation number. And then if we look at the buckets now, so anything more of .8 or -.8 is a strong correlation. Anything between 0.6 and 0.8, both plus and minuses, is a moderate correlation, and the other values, there is no correlation. If you want to learn more about correlation, I have this link here where you can do it on your own time. The purpose of this tutorial is the machine learning linear regression example. Right. So before I start analyzing the results, I'm going to visualize it using a heat map. So heat maps are always a good way of visualizing your correlation results. To run a heat map now, all you have to do is save this into, let's say, heat map equals, and then save this into heat map. And then down here, we can say g equals sns dot heat map, open brackets, put the hm, then run this. There we go, we have our heat map now. Additionally, I want to add the annotations in, so I can say annote equals true, run it, and I also want to increase the size of the annotation, so I can say annote kws equals, open brackets, what is it, size, I think, wait, sorry, let me remember it, so size, then 50. There we go. So now we can see our correlation within a heat map, and just to interpret the correlation now, we can see that the high values are the ones closer to the wider or the darker orange. So there is a strong correlation between visitors and marketing spend. So the more money we spend on, the more visitors we generate. And in terms of revenue, the more, revenue versus marketing spend. Again, this moderate to strong would say, the more marketing spend you have, the more revenue you expect to generate. Here they are ones just because they are comparing themselves with themselves, and then between revenue and visitors there is no correlation, and between visitors and revenue, which is exactly the same thing the other way around, there is no correlation. So what this is telling me now, so the way you would use this in a real life scenario is that you'd have about 1,000 variables, let's say, or you have 100 variables. You could pick the top 20, let's say, that have the highest correlation with your dependent variable. In our case is revenue. That's why I care more about revenue. And then only fit those features into your algorithm, since those features are the ones that have actually a relationship with your dependent variable. Right. The second way of helping us select the most important features is the feature importance from any tree-based estimators. So there are 3 steps into running feature importance. The first step is to split the data into X and Y. Then we run our tree-based estimator. I'm going to use a random forest and then run the feature importance. Now, let me say that I'm not going to go deep into how feature importance work or how decision trees work, just because it's not the purpose of this study. However, I have links here, which I'm going to show you later on. I highly suggest to read those links and try and understand how entropy works and how we're trying to reduce entropy and how we're trying to increase information gain, trying to understand the maths. Right. I'm just going to show you how to apply it now, so you know that it's there and it's one way of selecting the most important features. Right, to split the data now, we have to say x equals, and our x is going to be our independent variables, so everything but revenue. So I'm going to select my raw data set, which is, the pandas data frame, and I'm going to drop the revenue, and then say axis equals 1. So what this is going to do is basically going to save the whole data frame into x apart from revenue, and this is all our independent variables, and our y is literally going to be our data frame and then revenue. So if we print the shapes now, so we can say x dot shape and then y dot shape, and then we also print x so you can visualize it. We have a total of 179 observations in our x and 12 columns, and this is what you see now, the 12 columns. What you won't see in this x is the revenue, because revenue is saved in y now individually as independent variable. And if I print y, you can see we have a total of 179 observations, and all of them are in an array. So there is no column. Additionally, you have to know that if you want to pass data into an algorithm, you're going to have to turn your x into values. So what you can do is at the end say values. Then if I print x again, you will see it's not going to be a data frame anymore. It's going to be an array. Right, so now we need to initialize a tree-based estimator and then feed our x and y into this estimator to get the feature importance. To do this, I said before I'm going to use a random forest, but actually I'm going to use a decision tree. So if you follow the link here to the official documentation of SKLearn decision trees, you can read about how this decision tree works. However, I'm only going to use it for the feature importance. So I'm just going to copy the decision tree classifier with the random state, and I'm going to say decision tree equals, and then paste this decision tree classifier. Random state is so I can replicate the results. I also want to use, if we go back into the documentation, we scroll at the top, I want to use a criterion to be entropy, just because I need, criterion to be entropy, because because feature importance is based on information gain, maximizing information gain and minimizing entropy. So I can copy criterion, paste it here, and then say equals, and then copy and paste entropy. There we go. And there's another thing I usually do when I run decision trees. I run the max depth. So this is how many trees or leaves, let's just read it, leaves is going to expand until it's pure. So if I copy this, then say comma, paste it, and I want to go max depth equals 10. So if you have loads of variables and big data, make sure you keep this not too much, the depth, because it's going to take the higher the depth, the more time it takes to compute everything. Right, if I run this now, it's not really going to return anything. It just initializes the decision tree. What I have to do is that I have to feed x and y. So I can say dt.feed and then open brackets. And I need my x, comma, y, and then run this. There we go. Again, it didn't return anything because I haven't actually called anything back. I'm not going to evaluate how good this model is now. I'm going to jump straight into the feature importance, because this is the purpose of this video. To run feature importance now, all I have to do is say for I, comma, column in enumerate, open brackets, and in enumerate I have to put scroll at the top, and I have to put all my x variables. However, I don't want the values, so I'm just going to copy this without the values. So it's actually a data frame. Put it in here, and then I need to say print open brackets, and then I'm going to say the feature importance for, and then is, and then in my for, so this is going to be the feature. Then I'm going to say is, and then in here I'm going to put the feature importance. So I'm going to say dot format over here, and then first I need the column, so the feature import. So the first bracket is the column, and then the second one is going to be the feature importance, so the I, which is going to be the value. And to get the value, I'm going to go back into the documentation, copy and paste the feature importances here, and then call it. Additionally, I need to put DT at the top because this feature importance comes from our DT model we've initiated over here and feed it. And then into square brackets, I need to put I because I need the value. And if I print this, I can see the feature importance per our column or variable or feature. Additionally, I want to limit the 3f, isn't it? Yeah, I want to limit the decimal places into 3. So now what this is telling us now, just to interpret the results, is that the highest feature importance for revenue is marketing spend. So we knew this already. Then is actually visitors. So visitors is higher than everything else. Then we move into promotion. So the best promotion is actually the promotion blue, which again, we knew this before. And then we go down to the day, and the most important day, as we can see, is Thursday. So this is how you can use either the correlation coefficients, either the feature importances, to select the most important features to fit them into your model. In our case, I'm not really going to exclude any features. I'm going to use all of them just because there are not too many. But if we had thousands and thousands of features, we could run these feature importances from any decision tree classifier, and then order them, and then get only the most important ones that actually affect our Y variable. Right, the next thing we're going to do is to hit that like button and move on into our notes. This is the end of our EDA, so exploratory data analysis. And because we finished that, I do have some notes here. So please note that we have not normalized or scaled our data. So this is a procedure that you would usually do in EDA, but we don't have to do it. Our data is fine, it's not sparse. Please note that we have not done any feature engineering, created new features. This is again a step you would usually do in EDA or pre-processing. Please note that we have not joined multiple datasets together. Again, this is a step you would usually do in pre-processing phase. So remember, this is the data pre-processing phase with all the, not everything, but with some of the most important tasks or steps you would take within data pre-processing. And the last note I have is that please note we have not aggregated any of our data. So we haven't summed or averaged any of our data, which again is a step or is a process or is a task you would usually do in your pre-processing phase before you run your algorithm. Right, the next thing we're going to do is to split our data using holdout validation. So this is the step that we've explained in video 1, where we have to split our data and train our model based on a subset of our data. So let's say 70%, and then evaluate our model using unseen data. So let's say that the rest of the data, or the 20% or the 30% of the data, just to see how well we generalize and how well we avoid overfitting and how well we perform with unseen data. Right. So to do this, I'm just going to follow the link I have over here, which is going to take you into the official documentation of holdout validation. And what I'm going to do, you can come here and read how it works. But what I'm going to do is that I'm going to copy the code and then paste it and try to explain it. So, right. So let's start from the beginning. What this does is that it says, I want you to create 4 subsets. So the first subset is going to be the X train, X test, Y train, and Y test. And then this is the function from the SKLearn. And then I want you to take this X train and X test from X. So this X here is the X we've created before. So you remember how we split our raw data into X and Y. So X is all of our independent variables, all of our features, and Y is our revenue. So the X train and X test are going to have data from X, and then the Y train and Y test is going to have data from Y. And then the test size, I actually want to change this to train size because I have training there. So I want to use a training size of 80%. And then I want to use a test size, sorry, paste it, comma, change, oh, come on. A test size of 20%, 0.2. At the beginning, I said I usually try to split the data into 70, 20, and 10, but this is when I have time to iterate the model over and over again. However, because I want to keep the tutorial as short as possible, I know it's not short, I'm going to use 80 to 20, and I'm not going to keep repeating for evaluation. Right, so what else do we have? Random state is, I'm going to put 15, but this is so we can replicate our results. And if I run this, it worked, I got no error. What I'm going to do is that I'm going to print all the shapes so we can explain it. So dot shape, and then I'm going to copy this and paste it 4 times, 3 times, and then I need the X test, Y train, and then Y test. And then if I run this now and try to explain it, so my X train, it has a total of 143 observations and 12 columns. And then against this X train is the Y train, which is the revenue, 143 observations. So the answers, or what's the objective here, which is the Y variable, is the same with the observations, so it's actually correct. And then after I feed this into my linear regression model, I'm going to evaluate it on unseen data. So I'm going to feed this into the evaluation, these 36 observations. And while I do know the answer, which the answer is saved here, I'm going to ask the model to predict and then see evaluate how well the model did on unseen data. So this is why we have to split our data into these subsets over here using this method. Please note there are other methods too. There is the cross-validation method, which is quite famous, but for the purpose of this tutorial, I'm only going to use the hold-out validation method. Right, this is it for this tutorial. I'm going to finish the rest of the tutorial in the next video. I hope you enjoyed this tutorial and you've gained enough value out of this tutorial. And if you feel like you did, I would really appreciate it if you click the like button, subscribe to my channel, and enable notifications so you know when I'm going to upload the next video. In the next video, I'm going to be covering what is linear regression. Then we're going to be running our linear regression. Then we will be evaluating the model, so all the metrics. And then we will also discuss how we can use this model in real life scenarios. If you have any questions for this tutorial or previous tutorials, please let me know in the comments below. Or if you have different thoughts or new thoughts, please let me know in the comments below. Otherwise, thank you very much for watching, and I'm going to see you in the next video.